So we're going to start. Hi, everyone. Thank you very much for joining us. I know this is difficult times, and I really appreciate you being here. I really appreciate RDA to have this possibility to have virtual sessions. And thank you also for all the collaborators on the presentation and of the software source code identification working group. We're starting this session. We are the software source code identification working group. My name is Moran Greenpeter. I work for Software Heritage at the Archival Resource Center in France. I want to say that this session will be recorded and ask you to go to the notes. The note document is now available also on the slide, but in the chat. And please add your name to the participant list. We gather for you a very interesting group of people collaborating on this presentation to prepare use cases and identification schemas. We have Alice Allen, Anita Brandrowski, Roberto Di Cosmo, Martin Fenner, myself, Moran Greenpeter, Daniel Katz, John Kunz, Moritz Schubert.
So Moran, just to let you know, you're sharing your screen, so we can see the slides, but they're covered up by a bunch of other things as well.
Oh, sorry. Okay.
Okay. Thank you.
I'll do that. Thank you for saying that. Okay. All right. Thank you. Sorry about that. So we have a very interesting, I can minimize that. Sorry. That's the most I can do. Okay, let's start. We have a full agenda for you, so I won't read the agenda. We're just going to start. I give Dan Katz the opportunity to introduce our working group. Please, Dan, go ahead.
Okay, yeah, thank you. So this is an unusual group because we have 3 co-chairs. I think 2 of us are here, Martin and I. I don't think Roberto is on. And then we also have Moran, who actually probably should be the main chair because she's the person that actually does all the work. But in any case, here we are. So our all the other identifiers that already exist today. Let's see, I hear sounds like a small child, so if people who aren't speaking could mute, that would be helpful. Thank you. This group started at the RDA plenary in Berlin, and it is a group that is of interest to both RDA and Force 11, and so officially it's an RDA/Force 11 or RDA and Force 11 group. We had endorsement from the RDA tab. We also had endorsement from the Force 11 steering committee. In 2019, we had a meeting at the plenary in Philadelphia that kicked off the working group. ASCL and Astronomy Source Code Library and Software Heritage presented. And then there was a hackathon in Edinburgh at the Force 2019 conference that was led by Moran, and probably a bunch of other people on the call were there as well, although I was not. So, so the group has been going for a while now, and we are actually getting reasonably close to the end of the time for which an RDA working group is supposed to work. Okay, next. So okay, I guess I said a little bit of this, but the goals overall are to bring together the people that are interested in software identification, specifically source code identification, understand why there's an issue here, why this isn't just an obvious thing, talk about the different types of identifiers that can be used, what are the use cases where we need identifiers and how do those actually work. We want to talk about the pros and cons of different identifiers for different use cases, and to document our discussions. And so the goal here is to ideally to produce some concrete recommendations or at least some evidence that could lead to later recommendations for the academic community. Next, please. Thank you. So the group then has a set of goals that it put into its submission to RDA into Force 11. Thank you. Again, this is similar to what we were talking about in terms of what this meeting is going to do, looking at use cases and identifier schemas or schemes, thinking about where software artifact, software source code identification is relevant. And the things that we were thinking about initially were reproducibility, references to specific code fragments from articles or other documents, descriptions of dependency information. So one software could say what other software it's dependent on, and then citation of overall projects, not just the source code for credit attribution. We also then want to work with other groups because there are other groups that are working on citation and versioning issues as well, not necessarily for software, but sometimes overlapping with software. For example, there's a notebooks group that likely will start, and notebooks kind of our software and kind of our data and kind of our documents. So how exactly things work together is something we're trying to figure out. And the goal then is to have a set of guidelines for how people should actually proceed. And again, as I said, we're reaching the end of this working group period. And so we have an output that in theory is due in June of 2020 back to RDA, and that would be the end of the working group. I have to say, honestly, I don't know if that's practical or we should try to extend in some way, and I don't really understand RDA's policies well enough to know if that's going to be possible to do. So we'll have to see, but that's where we are now. Okay, next slide, please. Right, so the other thing that's worth mentioning is that Martin and I, who are co-chairs of the RDA group, are also co-chairs of the Force 11 Software Citation Group, along with Neil Chu Hong. The RDA Force 11 Software Citation Implementation Working Group. This is a follow-on from the original Force 11 group that was trying to develop software citation principles and did so. And the objective of this current group then is to take those principles and to figure out how do we actually implement them? Can we produce concrete guidance for software developers, for registries and repositories, for journals and conferences and publishers, for indexers, for institutions, for funders, that they should give to people that are submitting things to them that say, here is exactly how you should cite software that will lead to software being cited commonly and us being able to go through those citations and understand them. Sorry, for Yvonne, I'll just say that the notes document has a link to the slides as well, so you can see the full version. But I agree, if Moran, if you could click a little, maybe the underline thing in that window, that might be helpful.
Yeah, I'm sorry, I'm tried, but I think I need to stop sharing the screen to do so. So I waited for you to end your.
No, I think you can just. You should be
when
able
I
to
click
just.
on it. Yeah, it's moving a slide along. So I'm going to stop sharing and I will hide the bar just a moment.
Okay.
So it will.
Okay. Okay. So I'll just say then just quickly, the Force 11 group at this point has 4 different task forces that either are or have been meeting. One is looking at code meta and how code meta moves forward. Code meta is a metadata schema effect software that includes a crosswalk to a lot of other schemas as well. There has been a repositories group that is active and is meeting, that's coming up with a set of best practices, or at least good enough practices for repositories for how they talk to their submitters and for what they should be doing. There is a group for that we're calling a journals group that has publishers of journals, editors, conference proceedings, and that's trying to take some initial output that came from a different group that was looking at guidance. The guidance group provided some fairly straightforward guidance that we think is pretty close to useful. And in some sense, the journals group then is trying to take that and to customize it for different different sub-communities and to try to then try it out and make sure it works, that then could feed back to the guidance group. So yeah, okay, so that's the 4 of those, and I think I'm done and we can go on to the next slide.
Thank you, Dan. That was a great presentation of our working group, and I agree with you, the output is due soon and we still don't have a draft, but this session would be a good starting point to collecting the use cases that we have as part of the output. So now we'll continue to the use cases presentation. I'm so sorry about this black on the screen. I can't manage to minimize it, and I have only one screen because I'm at home. Sorry. You have the link to the full presentation in the documents, and I hope if you can also open it and follow with your presentation on your screen. So first, before going to use cases, we collected the software stakeholders in the scholarly ecosystem. We have a broad range of actors, and we should remember that each use case should be attached to an actor. It's easier to proceed that way. Normally, Roberto should be on the call and present our use cases. I'm not sure he's here. Roberto, are you here? That's a no, maybe. So I will continue.
I see Roberto on, although he's muted. So I don't know if he's trying to talk or not.
Roberto, can you unmute yourself?
Okay, and Roberto's now unmuted, although I still don't hear him.
So I'll proceed, and when we hear sounds from Roberto, I'll give him the floor. So we need to remember that a lot of at stake when looking at use cases. We have 4 different levels. We need to archive software to ensure the software artifacts are not lost. We need to reference to ensure that software artifacts can be precisely identified, and we need to describe those artifacts that it will be easily discovered and findable on registries. And finally, the most difficult part of this is giving credit to ensure proper credit is given to authors. This is the most difficult part, which is dealt also with the software citation implementation working group. If we look at different researchers' use cases, it's sorry again about the black on the screen, but you can see we have access and use software source code. We have reproduce an experiment detailed in an article, which needs only a reference, as you can see on the right. Reference of software source code used in an article, and algorithm, which also needs only a reference. We have search and find appropriate software source code using rich metadata. That's a describe, give and get credit, so that you know that's give credit is most difficult to most difficult use case. Let's see some concrete examples. So we have first example is a researcher wants to reproduce an experiment from an article. We have a very nice reproducibility challenge, the 10 years reproducibility challenge. Ask for authors to find their own source code and own article that they written 10 years ago, see if they can make only small modification, and try to run and reproduce the experiment they have written 10 years ago, and rewrite a report and share how this procedure happened, and if it was easy or difficult to reproduce the source code they have, their own use code, source code. So you can go on the slides and see the challenge and the experiment. Another use case is the reuse of software as a tool. If you are reading an article, and in an article, like in the example here, you have a link to the repository you want to reuse, access and reuse the software source code, but sometimes a URL gets you nowhere. Here with the PowerMap example, the repository was on Gitorious. Gitorious has closed, and so the link goes to a 404 error. That's another use case. And another example would be a link to the, maybe I hear Roberto coming in. No, Roberto?
Yes. Hi everybody. Sorry, can you hear me?
Yes, I can. Dan, can you?
Okay. Sorry for the confusion. My Zoom client crashed on my machine, so now I'm joining from the phone. Hoping it goes well. So what do you want me to do, and should I pick it up where?
Yes, please pick it up because you do it so lovely. Your slides are.
So
yes,
may you get back a couple of slides, just a second, because I was just disconnected, so I lost my. Yes, still one, very quickly. I will go through this. Okay, thanks. Stop. Okay, so the idea of the following slide is to present you a few concrete use cases that correspond to different needs that we try to classify in 4 different categories. One is actually to archive artifacts, make sure they are not lost. The other is to reference them precisely in such a way that one can pinpoint the exact source code one needs in a particular case, typically for reproducibility. Another is for describing a software project in general to make it easier to discover and find it. And another is to actually make sure the authors, whatever they actually are, actually get credit. I mean, these are really 4 different things, and not necessarily you had a single silver bullet that address all of them. So, but let's see the use cases. If we can move forward, or on to the next slide. Okay, in the case of a researcher, for example, myself, I have been trying, for example, I have submitted a paper to this reproducibility challenge. It's a typical replication study. What is a replication study? You find an article produced by somebody about chemistry, biology, physics, whatever, and you try to reproduce the same result. So the first step there to reproduce a result is to understand what the researcher has done. So you try to get the source code, the original source code, try to run it, see how it works. Eventually, maybe you want to rebuild yourself. But the first step is finding the source code. It was a very interesting experience to participate in this 10 years reproducibility challenge that has been launched a few months ago. So the challenge is very simple. So you need to find your source code for a paper of yours that you wrote at least 10 years ago. Okay, so you don't have it necessarily in your drawers. Try to modify it in such a way to make it run. See if you can reproduce results, and then write a paper that actually describes what you did, and make sure this paper is actually reproducible. So this time everything is in there. In the slides that you will get, there is a link at the bottom, and this reproducing and replicating the Occam's P3L experiment is actually one paper that we wrote with a colleague about an article wrote 22 years ago. Right? And surprise, surprise, the big difficulty there was to find the source code and the exact version of the source code. The rest was much easier. So this is one particular case. You need archival, you need reference. The other point is, imagine you want to reuse a piece of software that comes from somebody else. In this case, you need to access a software you did not write, I mean, software from somebody else, and you want to be able to use it. So typically up to now, most of the people, me included, I'll go back one slide, please. Okay, what people do, like me, I mean, this is myself, I'm criticizing myself in the next part of the paper on mine. What we suppose it was a good idea is to just point to a popular forge where software is developed. I mean, 8 years ago, this was on Gitorious. work of mine was on guitars. Unfortunately, Wikitoria is gone. So if you click there, there is nothing left. And then, next slide. Sometimes you also want to be able, in a paper of yours, in an article of yours, if you're a researcher, to be actually able to pinpoint the part of a potentially very big piece of source code to highlight the important parts, the segments where you made the particular ideas clear, where you did implement your fantastic insight to make things run quickly. And here is an example, again, in a paper of 8 years ago. What we did with a colleague was to actually copy-paste in the paper a simplification of the article. This is the picture you see on the left. But that was it. And what exactly, where can I find the exact corresponding source code, or should I sift through the thousands of files or versions around? What you want is to be able to put behind the pictures in your article a link, a clickable link. Actually, in the slide, this is really clickable, that brings you to exactly the piece of source code that you wanted. And so this means when you are looking for archival, it is not just enough to archive a zip file. This is not what you want if you want to get this kind of use case addressed properly. Then we can move forward once more. Okay, and here's another example. I mean, not necessarily a researcher, a scientific journalist or an activist may want to actually write an article describing some landmark piece of source code. This happened a few years ago when the Apollo 11 source code was popularized, when it was moved to GitHub. Actually, it was created much earlier. I mean, this is work by an incredible person who started doing this in 2003, not the guy who actually put it on GitHub. Anyway, journalists noticed when this was in GitHub, and they wrote nice pieces of description of the source code, pointing at places in the source code. But they used non-persistent identifiers. The result is it's a real pity. I mean, this beautiful article by Quartz, you can click on it and look at it. If you click on the links, you go on GitHub and you basically just get the 404. I mean, they were not using the right identifiers to go there. So if you move forward more, and this is a complete, clear use case, very precise. Now, at the higher level, let me highlight some other use case I see. I mean, when you are a researcher or an evaluator, there are issues about your career, your activity report. So for example, as a researcher, I have to write my curriculum vitae. I need to mention the software I create to contribute to when I want a promotion, when I want to apply for a grant application, when I need to write a report every 4 years. I don't know how often you need to do in your university. If I am a lab or a team director, I usually need to track the software production and the contribution, because when we write a report to describe what we did, we had a section on applications, and now people are starting to create sections about software, but they are created in a very ad hoc and crazy way. Then if you're a university or research institution, then this is even more sophisticated, because usually you won't have metrics, how many people are contributing to what software is used or not, should we do technology transfer, if somebody applies to get some money for some research engineer, should I give it to team number A, number 1, or number 2, or number 3, based on what? I mean, these are the typical case that we see, I'm in a bunch of panels and committee, and nobody has actually a silver bullet up to now. I mean, it's done by hand, it's complicated. And when you go in this way, please notice, you find areas which are, I mean, in these use cases, there are things which are different from what we usually discuss when talking about persistent identifiers, etc. First of all, the granularity can be very coarse. So if I'm a university, I am not really interested in which version or what software has been developed. I want to say how many important pieces of software have been created here. So you say CERN invented the World Wide Web. You say INRIA created scikit-learn, not a version archived somewhere. You need a way of describing this in a standard way. And then when you talk about credit, I mean, because now in careers means credit, giving credit to the authors, evaluating what somebody does, then my experience inside the theory and many other places that it is not just a matter of pinpointing an author or a contributor. You need to know what people actually did. And the role is much more than just saying how many lines of code you wrote. It is basically who designed the architecture of the software system, who is responsible for management, who got funding, who did the development, who did the documentation, who designed the algorithm, and a lot of things that are actually not present in the source code at all. And we need to keep track of them, and you need to have qualified information about this, not automatically create a list of contributors from GitHub, for example. I have seen these kind of things. It's definitely not something I want to see in an evaluation committee. So if we can move further, next slide, Ran, if you can. There are many more use cases here. You can see software engineer, digital artists, standards, registry, etc. Moving to the next slide.
This is me now. Thank you. Yes, thank you, Roberto, for this, for shedding light.
The reality is very much more complex than one can imagine, and seeing very precise use case is fundamental to actually, before actually designing solutions. And I stop here. Thanks a lot.
Thank you, Roberto, for shedding light on those use cases and on the scholarly ecosystem. Now we will move to our icebreaker activity. You go to the notes on page 2 or 3 now, because we have a lot of participants. And I will ask you by writing to propose a use case and saying, typing your name in brackets and then proposing a use case. I will stop sharing my screen. Maybe it will solve my screen problem here. I will give you 3 minutes for that. This is very nice. I already see a long list of use cases. I give you a minute more and we will proceed. Okay, let's continue. Now that we have warmed up with this icebreaker activity, we'll continue with other presentation about identifier schemes or schemas. We'll start again with Roberto, if you can join us for presenting hashes, the software heritage ID, and the AL ID. Please go ahead.
Okay, can you hear me? Is it working?
Yes. Yes,
Yes.
working.
Okay, fantastic.
Great.
Fantastic. Okay. So if you remember the 4 layers we mentioned before, so archiving, referencing, describing, giving credit, these are actually 4 different things we need to do. And for archiving and referencing, there is a modern technology which has been around for a while based on the evolution of version control system that is particularly interesting for one part of this, for only one part of this puzzle. What is a version control system? Let me just give you a short recap for people who are not software developers. I mean, when you are a software developer, you're actually battling with pieces of software. It can be very big, a bunch of files, a lot of people working on it. You make modification all the time because you need to try to fix bugs or add new features. So I mean, when I was young, the solution was I actually had a source code file which was the project -final.c. Then I had another which was the project that dash it really works.c. And then you had project dash the latest version.c. And after a while, you are basically lost. So what people did was developing tools that actually keep track for you of the version and evolution of the source code that you develop. And then once you have the tools, what you want to do is to see the difference between the version of today, that of yesterday, to merge two different contributions, to eventually create another version for testing something separately, to go back to the previous existing things. I mean, these tools are the basic carpentry tool for software developers today. They have been around for some 40-something years. So starting from a very simple tool, which is a local version control system. Then we moved to centralized version control system where you needed to have a server like CDS and Subversion, which are still popular today. And then around 2003, 2004, you had a huge change in technology. I mean, 15 years ago, because we moved to something which is called decentralized version control system, a system that allows you to evolve pieces of software, having each of the developers their own copy and being able to track what the other do without relying on a central server. If you want to do this, then you need to solve a complex problem. You need to attach a unique identifier to a piece of software which is independent on any central authority. So I have a copy of a piece of software on my machine. I must be able to find a unique identifier on this particular piece of software, and another developer on the other side of the planet with the same piece of software must be able to find exactly the same identifier without relying on any central authority. I mean, this is fundamental for having distributed version control system. Well, this is based on cryptographic signature, very strong cryptographic signature, and a marvelous idea by Ralph Merkel, a cryptographer from Germany who's still alive, who invented a way to export this cryptographic signature, not just to a single file, but to a full tree structure as you may have on your machine. I mean, this technology has been around for some 15 years. It's very popular in Git, which is the most popular version control system, but also in Mercurial, another distributed version control system, in Bazaar, in Darts, many others like this. It is the same technology used in Bitcoin. It is the same technology in distributed file system. I mean, once you find a powerful concept in computer science, it eventually gets applied. So why this little piece of information here? Because actually, a lot of people have been trying, even as researchers, to actually use, for example, GitHub as a reference. Okay? So they say, I put something on GitHub, I put the pointer to GitHub, and that's it. I have archived it and I have reference there in the content. If you remember the example we have for 11, it doesn't really work very well because on GitHub things can come and go. It's not an archive. And because people do not actually know what they are linking into. Usually they use URL, which are fragile and not the real independent identifier. So let's see, if we move to the next slide, what are these identifiers as we implement them in software heritage. So software heritage is a universal archival source code, an archive, not a development platform. We are not GitHub, it's just an archive, nothing more. But the advantage is when you put something in, you will find it later on. And then to reference anything in software heritage, you can use the schema that you see here. I do not know how to point, but let's see at the big yellow box on the top left, if you look at there. So the schema of the identifier is very simple. It's a kind of a URI, Universal Resource Identifier. The prefix SWH is to tell you what follows is actually an identifier in the software heritage schema. Then you have a schema version, because the schema can evolve. Then you have a description of a tag, which is a description of the object type. And actually we have identifiers for a file content, for a full directory, for a revision, for a release, for a full status of the version control system, what we call a snapshot. This is many thanks to Mr. Merkel, Professor Merkel. And then after that, you see this object ID is actually a cryptographically strong hash, I mean this signature, which is today based on salted SHA-1, the same as Git. We made this choice to be Git compatible, which is a convenience. And it can evolve in the future. We have version 2 with a stronger hash or something like this. It is resolvable on saturation, and we added some context information that you see in the yellow boxes below. For example, you can say, I'm pointing to this particular file content here, and what I'm interested in highlighting are the lines from 64 to 72. This is what I want in my research paper to be able to say, you see, the core algorithm is these 7 lines here, or 20 lines there. And then we also add some other contextual information that we are actually enriching right now. Today you can point to the origin. For example, the same file can be present in thousands of different projects. If it is exactly the same file content, we have the same exact identifier. So if you want to know where it has been found, it's better to add this origin information so you know the context where it is. And so just a comment about this. These kind of identifiers were not invented today. They were invented 40 years ago. They went mainstream 15 years ago. Now they're really mainstream in software development. And they are basically useful for the reference part. It's not for citation, it's not for credit, it's not for description, it's for finding exactly the exact version of an object without relying on any kind of central registry authority. And of course, this works well if you have an archive. If you have a reference to an object, nobody has a copy, you lost it. But if there is an archive somewhere, or somebody has a copy somewhere with this reference, you will be able to find it. And today that we are in this coronavirus crisis, let me say that we usually use a mental thought to explain why these identifiers are so important to use in research papers, is that, imagine in 20 years there is another outbreak like this one, and we find a paper dating in 2030 with somebody that has a pointer to a fantastic molecule that can kill the virus. If you the pointer to the description of the molecule is just a URL, we are all dead. If it is a persistent identifier based on a registry, we should be really, really sure that we know the registry is really maintained for 20 years, doesn't depend on funding or whatever. If it is a cryptographic hash like this one, who cares? At some moment, if somebody has a copy, even if no archive is left, you can always send a distress email to everybody around the planet saying, hey, we are desperate, we are looking for a molecular formula in a file that has this signature. Please compute the identifier locally on all your machine, all of your archive. Let's see if you find one. If there is a copy around the planet, somebody will find it and we are safe. You see, the idea is kind of extreme, but gives you an idea why decentralized is different, why decentralized is important. But it is only useful for reference, nothing else. Okay, so we think I will stop here, and this is just what I want. No. Yes, I have still one slide to go to. And so if you want to go up, so instead of having just a reference, that works well if you also have an archive, you also want to describe and cite. That's a completely different business. Then you need to have metadata in a proper format. You need to have a persistent identifier that points to this metadata, to a landing page that describes the object. You need a curation mechanism to be sure that this metadata is correct, that the list of authors correspond to what you expect to see, etc., etc. So we have been implementing this kind of workflow in France with a local open access portal. I mean, it is a national French open access portal, which is called HAL, Hyperarchive Online, whatever. And so a researcher, what the researcher does, she can deposit in the open access portal a metadata description of the piece of software with a particular version of the software. Then there is a review process going on with real reviewers, like in Archive, there are reviewers in HAL, also reviewers. And these reviewers look at the metadata, interact with the authors, make sure the metadata is curated. And once the metadata is curated and the reviewer and the author do agree, okay, that's fine. And that's the moment where the software is actually transferred to software heritage, where it is archived. And we provide back the pointers, I mean, our unique identifiers, the cryptographic hashes, that are also showed on the web page. So you see this kind of interplay shows you how on the low level, when you're looking about reference and archive, you are really much better off using intrinsic identifier like this kind of hashes for our identifier. And when you go up, you really need, for description and citation, to have a persistent identifier based on registry. There are also middle grounds. You could also have the metadata inside the source code, but that's another story. Okay, stop. Thanks a lot.
Thank you, Roberto. Thank you. I will move along to the DOI with Martin Fenner. Please, Martin, you have the floor.
Thank you. I will briefly talk about digital object identifiers, DOIs, and the use cases are all around citation. DOIs are citation identifiers. They're good for that. They're bad for some of the things we talked about earlier. We support citation by providing the metadata that are typically needed and by providing linking to other resources. We have about, well, that was yesterday, 128,000 DOIs. So that is a tiny number compared to the source code that's out there in the repositories, but it's also a nice number. And you see a little graph on the right that this number is growing, which is mainly thanks to the repository Zenodo, which one of those starting with this a few years ago by, for example, a very nice integration with GitHub that makes it easy. You see that the growth, which was exponential and 2 years ago now has flattened a little bit. So maybe we have to do more to sort of encourage that this is a way to identify software if you care about citations in literature, for example. So I picked an example from a preprint from bioRxiv where a piece of software is cited in the reference list. And what's important is not only we have all the metadata to format the citation, but more importantly, that there is services built around that. So in this case, Crossref, where the DOI for the preprint is registered, tells us that there is something in the references that is coming from data side, and then we figure out, oh, that's software, and then currently we just expose this and show this to people, but there's of course all kinds of workflows possible from notifications to aggregations, etc. And we're in the middle of some of these things. This is not just referencing software in the literature, but this can also be funding. This could be institutions, linking software to institutions. And it can also be linking software to a person. And there again, it's not just metadata, but with ORCID, we have an integration. Whenever you register a DOI for software, for example, at Zenodo, we automatically put this in the ORCID record of that person, assuming the person has given us permission once. Well, one permission is good for 20 years. So that we can sort of build all these connections from software to other resources. There's no time to talk about more trickier things like versions, linking software to data sets, where software was used to generate data, etc. But I think you get the idea. Thank you.
Thank you, Martin. I'm going to move along to John. Please, John.
Yeah, thank you, Maran. So the Archival Resource Key is a persistent identifier that comes with no fees. 3.2 billion ARCs have been registered by, at this point, over 590 institutions to anything digital, physical, or abstract. Resolution is unusual. It's decentralized, or if you wish, you can centralize it via n2t.net. The way things are done, assigners can choose their own identifiers, like legacy commit identifiers, or they can generate them. And if you're generating it, that means generally opaque IDs, such as UUIDs, or using a generator like the Noid software. And these are registered with a redirection target URL. An example of an ARC is shown on your slide there. Reading left to right, there's a label, and then as usual, there's something that identifies the assigning organization, 1, 2, 3, 4, 5, the institution. Then there's the thing being described. After that, you can have various qualifiers identifying contained subthings and optional variants. The citation guidance is to cite them as usual in actionable form, so you put a host name in front. ARCs are appearing in the usual places like the Data Citation Index, Wikipedia, Wikidata, ORCID profiles, Internet Archive. That's it for me.
Thank you, John. Thank you. And I'm going to move to the ASCL ID. This slide was prepared by Alice Allen. We have Dan here to present her slide.
Right. So ASCL is the astronomy, I always think astronomy, astrophysics officially source code library. It's primarily a registry. It has a little bit of a repository function as well, but it mainly is intended to point to astrophysics source code that exists somewhere else and to provide labels for it. Items are ideally registered by authors in ASCL, but sometimes the journal editor maybe sees that there is software that's described in an article, and they then register that software in the registry. Again, the main purpose of ASCL IDs is to identify software that appears in the astrophysics literature, so that when somebody reads a paper, they can then go back to that software. Identifiers look like ASCL : a date, and then an item number. And so there's no meaning associated to this. It's just sequential. And one of the interesting things with astronomy or astrophysics is that it has this astrophysics data system that really indexes almost everything in astrophysics and does it somewhat uniquely, and is probably much more curated than many other identifiers. So ASCL identifiers, software that's indexed by ASCL, is then in turn indexed in ADS. And then this lets anybody that's in the astrophysics world cite software by using its ASCL identifier.
Thank you, Dan. I'm going to give the floor to Anita for the AR IDs.
Thank you. So yeah, just like the astrophysics example that we just heard from Dan, RIDs are essentially mostly used in biomedicine, although there's been more and more in chemistry recently. There is a registry called the SciCrunch registry, which is part of the aggregated RID registries or repositories system. And a lot of these cover different broad areas. So we don't actually handle things like plasmids or mice. We have registries and repositories that are outside of the group here that would handle those. The SciCrunch registry itself does handle quite a few software tools. and it ensures uniqueness because it is a it is a curated system. So we know that we have a unique set of tools, software tools. And our goal, just like with the astrophysics registry, it was originally to only register non-commercial software products of research. However, the issue with that was that the authors, as soon as they started using the system, they started to put in commercial software tools. And in fact, the commercial software tools, for example, tools for microscopy are put together by every company that makes microscopes. And those things don't really have software code that's available. So we needed a system to be able to quickly register those things as authors are adding these to their papers. And, so software projects are being registered. These identifiers are not very good for identifying a particular line in a source code because we often don't know excuse me, what the source code is. But the format is very simple. So there is the RID :SCR and then some number of numbers. And then what that does is it provides like a short handle-like thing that ends up going into a persistent unique ID that ends up going into the methods section of the paper, which is where it's being asked for. And they're also growing. Their use is growing fairly quickly. We're about 219,000 RIDs that have been used in literature so far. And if you want to look at what this actually might look like, this is funny because this is actually a paper that was from our group. It was on page 2 of Google Scholar. But if you look at that, that Google Scholar result. So this is one of the most common RIDs that's being used. And this one's so far been used in 1,200 papers. So it's quite a bit of the biomedical literature that now either asks or requires authors to do this task. And so the registry is growing because of authors. But again, because of that, we end up having to deal with use cases such as what do you do with commercial software? We certainly want to make sure that those are unique. So I'm not sure why the words are kind of covered here by various things, but I think I'll just stop there.
Thank you, Anita. Thank you. We're going to move to Moritz with the SWMath. Please, Moritz.
Yeah, hi. So we have a software repository for mathematicians. So we collect research software in mathematics. And the versioning number is quite simple. So it's just an ID which is counted up. As a difference to other repositories, one does usually not enter the software oneself. This is done by editors. So reviewers of mathematical articles identify articles that mention a software, and then the software is added to a database, and the article that first describes the software is seen as the standard article. So this is more like the old habit of software developers in mathematics and to some degree also in computer science, who say, if you want to use the software, please cite that in that paper. So these are then the standard articles where authors describe what the software is about, and there can be more than one standard article assigned to one SV mass ID. So it's more a coarse-grained classification or identification of software, but it's still very useful for mathematicians that want to use the software. Based on this information, we have different information about authors. The authors are derived from the research paper that describes the software and not from the GitHub commit history. And Also because of the relation to the scientific papers, we also have a classification of the software, because the standard article that describes the software have been classified according to the mathematical subject classification schema. Yeah, and of course, having defined those identifiers, we can find those identifiers in literature published after the first standard article was published, and that's also something which is done by editors and semi-automated methods that go through articles and try to identify which software has been used here. And this there's a lot of manual effort to check if all the mentions and if this heuristics to detect the software mentioned in the papers is correct. So we don't rely that the mathematicians use the software identifiers. We try to detect the mention of the software in the papers manually, which is really, I mean, it's an uphill battle somehow. Yeah, we can link back and forth with Wikidata and software heritage. And speaking of Wikidata, that would be the next topic. Yeah, what we also do, we started to link our software identifiers to Wikidata items, because a lot of the software that we assign identifiers to have also Wikidata entities. And as we saw, there are quite some initiatives to collect like a database of software. We want to make sure that this information is open and that we can also link other identities, like for example our ID. I think there is an intersection of our ID identifiers and SVMAS identifiers, and I think Wikidata as a central repository would be a great thing to do. Yes, and you don't have to be afraid that you generate duplicates on Wikidata, because this is possible by design, and later on one can merge those duplicates. I think most of you know Wikidata. It's a multilingual database. It's connected to Wikipedia articles, and also a lot of publications are today in Wikidata as data entries, as items. Okay, that's basically that from my side.
Thank you, Moritz. Thank you, and thank you everybody for this really fascinating description and detailed information on all identifier schemas. Our next activity, which will be the next slide, would be go back to the notes and identify which is the identification target of a use case. So here I have the collection of different targets that you would like to identify with specific use cases. So we have the software artifact, which can be a software source code or an executable. And in the software source code, it can be the dynamic artifact or the archived copy of a specific layer with different granularity. It can be also less specific. It can be also the software concept or project, a home page, or just this description in the registry. And it can be other things associated to the software, which can be complementary artifacts, maybe containers, data, articles, or documentation. So now we go to our next activity. So I invite you all to go back to the notes and with a comment. I don't know if you see the black box on your screens, because I don't have a possibility to minimize that. I propose that you will put a comment on the use cases that were listed, that you, on your use case, on another use case as you wish, of the identification target I can put again the list slide, and I will give you 2 minutes, 3 minutes to do that. So maybe a little more, but I'm going to prepare our breakout rooms, and we'll discuss that after that. I see that you're all thinking hard on the question, on the use cases. I see some adding the targets to the use cases. I will give you another minute to finish up, and I will prepare 4 breakup rooms that I will assign automatically. Okay, thank you. We'll be moving on to the breakout rooms. I prepared 4 breakout rooms. I'm sorry, I'm not asking you which one you prefer being on, because it will be more work for me to choose which one of you to which room. So I did something a bit mixed. In the notes, you have on the final page the breakout rooms with a concept use case like reproducibility or reuse or credit, but you should pick up a more specific use case for your group. Of course, I propose that you will introduce yourself, then talk about the use case and try to document the use case on the proposed template. So you have also the link to your template with your room number. And I hope that you will see your room number when going to the room. So I am going to do that now. You'll have a button to click, and I'm opening rooms to you all. If anyone wants to say something about the room, about how it went.
So yeah, just really quickly, I could say for the reproducibility one, room one, the thing that became clear to us after a bunch of discussion about reproducibility in general was that related to source code identification, we need identifiers that identify the exact version of the software that was used if we want to reproduce it. And it isn't clear from the talks that we had about the different identifiers, which of those actually do that. And if the identifier doesn't identify the exact version, how that's done. So I don't think we should discuss it at this point, but that was the result was that kind of discussion.
Okay, thank you, Dan. Maybe one other group wants to share?
So we had some discussion in group, are we in group 3 or group 2? I think we're in group 2, okay. We're talking about access. And we did a lot of discussion in terms of repositories versus archives. And then we essentially, what's a repository, something like a Git, versus what's an archive, something that, you know, becomes more persistent. Obviously archives were better, but the amount of code that's in a repository such as Git is just huge and overwhelming. So we're very excited about this software heritage project. We discussed the persistent identifiers in registries as well, because those, John Kuntz thought those would be perfect places to then be able to point to the most recent version of the software. Or if, you know, if the software moves around between one repository and another, then it would be, you know, those persistent unique identifiers might be able to point back to the place where the thing actually lives. But we also then thought that the hashing functions would be extraordinarily useful in terms of being able to actually determine whether the software is the same as the software as was used. And that would potentially obscure, you wouldn't have to necessarily see the code. You would just need to know which hashing function was used. And at least you could know.
Thank you, Anita. I think we have passed our session time. So I will just say thank you, everybody. I know we didn't have the last two groups reporting back due to the technical error, but I want to wish you a very good day. Stay safe. And
can I
thank
stop you from wrapping up, Moran?
Yes, go ahead, Martin. But yes, go ahead.
No, just one sentence, because we have done something nice. What's the next step? So should people continue in the Google Doc, and then this will be shared and stuff? So just something like that.
Yes, this is perfect. Yes, you should continue in the Google Doc, and we will continue the Google Docs, because this will be a basis for the output of this working group. So maybe we should do a mail on the mailing list and mail to all the participants here in the session that we should continue this discussion on another time.
Perfect.
Well,
Great.
thank you. Breakout rooms were fascinating. It's my first time.
Me too.
Thank you.
Yeah, it worked pretty well.
It did. Thank you, everybody.
Any suggestions on how to follow?
Good night, everyone.
I will send an email for all the participants on how to follow the
Thank
work.
you, Moran, Daniel. All right, bye-bye.
Okay. Thank you.
Bye.
Thank you. Bye-bye.
Thanks, everybody.
Thank you.
Bye.